Howdy, AP PreCal. It is Ms. Kosh. This is day 2 of my polynomial notes. So I broke things apart a little bit, and I'm doing part of 1.5 and maybe all of 1.6. And on the same day, I did part of 1.5 in my day 1 notes. So hopefully this isn't too confusing. So one of the big things that they like to do in AP PreCal that I hadn't really taught before was they like to do inequalities of everything. And so we start inequalities this year we start in the course with polynomials. And so they're going to give us something like, they're going to tell us that maybe this function is f of x, and they want to know where is f of x greater than 0. Well, if they draw us the picture, life's not so bad. You may notice this, I made a bigger version for the previous video. So we want to know where is my graph, sorry about the previous notes, but we want to know where is my graph above the x-axis. Well, let's do it over here, it's a little less cluttered. We're going to be above, notice on this one, if I had made it f of x is greater than or equal to 0, our life would have been a little bit easier because we wouldn't have to think about what's happening here at a. But because it's just greater than 0, so we're going to go from negative infinity to a. I think I said that point A has an x-coordinate of a. And then we're going to pick it up on the other side of a. A is equal to 0 and not greater than 0. And then we keep going until we get to 0. We don't get to include that. And then we pick it up again and we go from e to infinity. Okay, and so we had, in our last video, or in a previous video, we had made this a sign diagram. And so the sign diagram can help us figure this out also. One thing that we might do with this, I'll show you in a different problem. Okay, the next one here, sorry, I was thinking out loud. Okay, on this one, we want to know when is g of x less than or equal to 0. So this is now my g of x. And so less than or equal to, oh, that's annoying. Here is a place where it's equal to 0. So we might say something like, if we have a particular point, it's tricky to put it in interval notation. So on this one, we described the set of all these values, or the domain of this range of solutions. Do I want to use the right word, range? We have a whole bunch of answers that make this true, and we express them in interval notation. Because this one is going to have the point A is equal to 0, which is a little annoying, and it's hard to do interval notation with just one point, I'm going to switch to what we call set notation. And so it's the set x such that is how, and sometimes you'll see people do such that and they'll draw a line like that. Either way, my normal use of set notation would be the colon, but there's nothing wrong with this. We read this as the set such that the set x such that, the first one we're going to say x is equal to a because that's where it's equal. And then we want to know where are we less than, so it's between, we hit the, I don't know if you can see this, but we hit the x-axis at 0, 0, and then we come back to f. So, and then comma, we want 0 is less than or equal to x is less than or equal to f. Notice I'm using the equal signs because we can equal 0. So at 0, I had the point 0, 0, and at f, if I had like g of f, that would equal 0, which is fine. And then, so we're below the x-axis, and then we're going to be, or what was it, x is now greater than or equal to h. That's greater than or equal to. And so this part of it, we could use interval notation 0 to f, pick it up again and go from h to infinity. But we don't really talk about this with interval notation, so I just switched to the set notation for all of it. I don't know that AP is going to ask a question quite like that, but there we go. Okay, so life isn't so bad when they give you the picture, and you can kind of just see, oh, look, I'm above or below the x-axis. But now we have to pay a little more attention when they give us equations. So this first one, it's already factored for you, which is great. I like to do the sign chart. So we're going to find our zeros, and to be honest with you, no, I'm going to do it this way. I have that this would equal 0 if x were 3, -1, or -4. Okay, so what I will do, but notice on here, I don't want to equal 0. So when I do my sign diagram, I'm going to have -4, -1, and 3. I'm going to just use a little dotted line instead of the dash from before, because this is reminding me that I cannot be equal to those values. And so up here I could have done the same thing if I'd made a sign diagram, but I intentionally waited to do it now. Okay, so now what I like to do is I like to plot a point and plug it in and see if it gives us a true or a false statement. Or sometimes I think in terms of positive or negative. In this one, we want everything to be positive. So if it's positive, sometimes I'll put a T in F for true and false. Sometimes I'll put a plus and minus for yes, it's positive, no, it's negative. Sometimes I'll put a check mark like yes, this interval meets the requirement. I kind of do some variation of that. Okay, so I'm going to take the easiest number to plug in is 0. When I plug in 0, I get 3. So I'm going to say this, plug in 0. And I get a positive when I plug in 0 here. I get a positive here, and I get a positive here. If I have a positive times a positive times a positive, that is a positive, which is greater than 0. So this part today, right now, I think in my answer key I use plus and minuses, but right now I'm feeling inspired with a check mark. Okay, now let's find something in, well, what I notice is that there are no repeated zeros. We don't have any sorts of multiplicities happening. So it should go positive, negative, but let's just make sure, okay? And so I'm gonna plug in, well, let's see, we could plug in -2. When I plug in -2, I get a positive, a negative, and a positive. So a positive times a negative is a negative, which is going to be less than 0, so that is not meeting my requirements. Okay, I did not save myself enough space. Let's think about if I plug in 4, I get a negative, a positive, a positive. So a negative times a positive is a negative, which is not what I want. I want something positive. Likewise, we think we should get something, we'll get a check mark here. Let's try -5, or anything more negative than -4. So -5 makes this 3 minus a negative is going to become a positive. So this whole thing is positive. This one, -5 is going to give me a negative. -5 is going to give me a negative. And a negative times a negative is a positive, which makes this a true statement. Okay, so our final answer, which I did not save myself room to write. Here we go. My final answer would be from -infinity to -4. The dotted line reminds me to use a soft bracket. Don't want this interval. Then we're going to pick it up again. These remind me, soft brackets, -1 to 3. Now, if you were so inspired to write this in, if you liked that set notation so much, do you want to do that again? So set x such that x is less than -4, or -1 is less than x is less than 3 would be one way to write that in set notation. But it was less important there because there wasn't a particular spot it was equal to. Okay, the next one, we have zeros at x equals -3 and +5. And we can equal, so this one, -3 and +5, I'm just going to use the solid lines. And so let's plug in 0. So if I plug in 0, I don't know why I wrote out the word, whatever. I get a positive squared times a negative, which gives me a negative. Is negative less than 0? It is. So that interval works. Okay, now let's plug in -4. -4 gives me a negative, and then I square it, plug in a -4 here, and I get a negative. A negative squared becomes a positive, times a negative is a negative. And that is what I want. Okay, because we wanted it to be less than 0. So that gives me a true statement. Now let's plug in something bigger than 5, say 6, plug in 6. So this gives me a positive, squared is still positive, times a positive, gives me something positive, which is great, but so a positive is not less than 0, that's a false statement. So because it does include this, we can just go ahead and say our answer goes from -infinity to 5, and we can use the hard bracket. Those are fun. Okay, that was, I think that's a good stopping point for this video. That was the polynomial inequalities, and we saw inequalities all year long. So every function that we studied, they were like, oh, more inequalities. Okay. So if you get a good foundation, fantastic, that will help you. If you don't get a good foundation, don't worry, you'll have a chance to understand it because it doesn't go away. All right, like, subscribe, comment, all the things, and I'll see you in the next video.